Hey students, lesson 8.1 here. We're going to learn about Pythagorean's theorem, or review it, and learn a little bit more. In this lesson, we're going to learn how to use Pythagorean's theorem and its converse, and also how to identify Pythagorean triples. And we're going to learn one other property about the Pythagorean theorem that you haven't learned yet. So go ahead and do the review. I'll check back with you. All right, so here's Pythagorean's theorem, just a reminder. If a triangle is a right triangle, then a squared plus b squared equals c squared, where a and b are the legs of the right triangle, which means the two sides that make up the right angle. And c is the hypotenuse of the right triangle, which is the longest side of the triangle, the side opposite the right angle. Okay, and then the converse of that, it says that if you have a triangle where a and b are the legs and c is the hypotenuse, if a squared plus b squared equals c squared, then that has to be a right triangle. Go ahead and do 6 through 8, and I'll check back with you. All right, so we're going to use the Pythagorean theorem here to find the length of the side Ln. And Pythagorean's theorem is a squared plus b squared equals c squared, where a and b are the legs and c is the hypotenuse. So we're going to substitute 8 and 15 for a and b, and Ln for the hypotenuse. And then we're just going to simplify that. 8 squared is 64, 15 squared is 225. And 64 plus 225 is 289. And then to undo that square root, we're just going to take the square root of both sides. Square root of 289 is 17. The square root of ln squared is ln. So, and then one other question, it says, does this form a Pythagorean triple? For your information, a Pythagorean triple is where you have whole number solutions to Pythagorean's theorem. And since we have whole numbers here, 17 and 8 and 15, it is a Pythagorean triple. Go ahead and do the problem 1. I'll check back with you. All right, problem 2. Here we're going to find a leg of the triangle, and we're going to put the answer in simplest radical form. So again, Pythagorean's theorem, a squared plus b squared equals c squared. Substitute the values for the appropriate letters. A and b are legs, so that can be 10 and x. And the hypotenuse is 16, that's c. So then we get 100 plus x squared equals 56 when we simplify those squares. Subtracting 100 from both sides, we get x squared equals 156. Taking the square root, the positive square root of both sides, we get x equals the square root of 156. Now we're going to write that as a product of the greatest perfect square factor that 156 has, which is 4 times 39. Now 39 doesn't have any perfect square factors, so we broke that down as far as we can. Square root of 4 is 2. So in simplest radical form, the length of the missing side is 2 times the square root of 39. All right, another problem. It says Jamal leans a 12-foot ladder against the side of a house. Let me draw a little house here. And there's a ladder leaning against there. The base of the ladder is 4 feet from the base of the house. To the nearest tenth of a foot, how high on the house does the ladder reach? The ladder is 12 feet long, so let's label that. This is 4 feet here. Now we have to assume that that's a right angle for this to work. But if it does, then we can label that H and use Pythagorean's theorem. And the legs are H and 4, and the hypotenuse is 12. So we get H squared plus 16 equals 144. Subtract 16 from both sides, and we get H squared equals 128. Take the square root of both sides and approximate that to the nearest tenth, and we get 11.3 feet up on the side of the house. All right, we try that. Fill in what you think the reasons are. All right, identifying a right triangle. Here we're going to use the converse of Pythagorean's theorem to see if this is a right triangle. And the converse says if a squared plus b squared equals c squared, then the triangle is a right triangle. So we want to check, is this true? Now remember that A and B are the two legs, so they have to be the shortest sides, so make sure you substitute that way. So we're wondering if this is true. So we're going to do 12 squared, 30 squared, and see if it equals 32 squared. 32.5 squared. All right, and if you do that, you get 156.25, 900, and 1056.25. And if you add those two up, they equal 1056.25. So indeed, this is a right triangle. So we're going to say yes, a triangle with legs 12.5 and 30, and a hypotenuse of 32.5 is a right triangle. And that's by the converse of Pythagorean's theorem. All right, let's try that. All right, the last thing we're going to learn is that you could tell whether a triangle is acute or obtuse by using Pythagorean's theorem. Theorem 8.3 says that if the square of the longest side is greater than the sum of the squares of the other two sides, then you have an obtuse triangle. And Theorem 8.4 says if the square of the longest side is less than the sum of the squares of lengths of the other two triangles, then you have an acute triangle. So in this one, c squared is greater than a squared plus b squared, and that makes the triangle obtuse. And in the other one, s squared is less than t squared plus r squared, so we have an acute triangle. So in problem 5, we're going to try and decide whether this is an acute, obtuse, or right. So we're going to do 4 squared plus 9 squared. And see what that equals. That's 16 plus 81, which is 97. And then we're going to do 12 squared, which is 144. And since 144 is greater than 97, we're going to say that this triangle with side lengths 4, 9, and 12 is obtuse, according to Theorem 8.3. All right, that's it. We're up to the lesson check. Go ahead and do that, and we'll talk about it next time we meet in class.